So I drop the 1, negative 2 times 1 is negative 2, add it, negative 7, multiply 14, add it, 16, multiply negative 32, add it, negative 12, multiply negative 2 times negative 12 is 24, and I get 0. And I'm happy because I get a 0. This is 1 less because I've taken the x out. 1x cubed minus 7x squared plus 16x minus 12. Now I pretend this is my new equation, right? Type that one into my calculator. What do I get for an x-intercept? What do I get? 2. So remember, my factor is x plus 2. So I'm going to write it down here in the corner. But am I actually looking for the factors? No, but I use my factors to solve, correct? So I'm still going to write my factors at the end. This one here is x minus 2. So I would write out all my factors and then solve from there. That's what I do. Because then if it says factor, I'm done. If it says solve, I go one more step. Make sure you're paying attention and not on your phones. The 1 drops. 2 times 1 is 2. Add it, negative 5. 2 times negative 5 is negative 10. Add it is 6. 2 times 6 is 12. Add it is 0. And I'm happy because I got a 0. It's an x cubed. I took an x out, so I'm left with x squared minus 5x plus 6. If I can't factor that, I'm done and I write it as a factor, right? If I can factor it, I do. So I can. So I'm what times what equals 6, what plus what equals negative 5, and I get negative 2, negative 3. X minus 2, x minus 3. I square that 1. The moment I square one of the factors, I have a point of tangency at that factor, correct? I have a multiplicity of 2 at that solving, yes? So to solve it, I just set each one of them equal to 0. I go x minus 3 equals 0, because it didn't say factor. X plus 2 equals 0. X minus 2 equals 0. This one gets me x equals 3. This one gets me x equals negative 2. This one gets me x equals 2. Multiplicity 2, because that's the only way I know when I'm solving it that there's 2 there, if you write multiplicity 2. If you don't write multiplicity 2, I assume there's 1. True statement? So if we want to write it as a final answer, I see it like this. X equals 3, comma, negative 2, comma, 2, multiplicity 2. The next one I picked to make you do decomp. If you haven't noticed, every single one gets a little bit different, a little bit harder. Okay? I know this one's a decomp, or, worst case scenario, quadratic formula, because it has a 2 in front. I can't do product sign, right? What one works first for this one? X equals what? So I know my factor is x plus 1. I'm just going to go up here. Okay. Then I have countdown. 3, 2, 1, 0. Cool, I can. So I go 2, negative 5, negative 4, 3. Remember how in transformations I said if you don't remember to have a 1 in front of your x, you're going to get them all wrong, and then some people didn't listen to me on the test and got them wrong? Same thing here. If you don't check if you can rocket count, you're going to get at least one question where I'm going to make it that you can't actually rocket count and you need a placeholder, right? Of course you're going to get one of those. That's the challenger question. Of course you're going to get one that's missing an x. Okay? So, I drop the 2. Negative 1 times 2 is negative 2. Add it. Negative 7. Negative 1 and negative 7 is 7. Add it. 3. Negative 1 and 3 is negative 3. Add it is 0. So I get 2x squared minus 7x plus 3, and I try and factor it first. I don't ever go right to the quadratic formula. So what times what equals the outside? 6. What plus what equals the middle? Negative 7. And it's going to be negative 6, negative 1. So we get 2x squared minus 6x minus 1x plus 3. And we group. Put a plus sign between our brackets. We get 2x, x minus 3, and I take a negative 1 out, x minus 3. If you're still someone who can't factor, get past denial. Get to acceptance. Come and ask me to help you. So those are my two factors. And there's all three of them. I set them equal to 0 because that's getting me my x-intercepts. It's also getting me to solve. So it's the same as the quadratics in grade 11. We just have extra factors. Instead of having 2, we have 3 or 4 or 5 because we can go up to degree 5. X plus 1 equals 0. 2x minus 1 equals 0. X minus 3 equals 0. I get x equals negative 1. 2x equals 1. X equals 1 over 2. And then x equals 3. X equals negative 1, 1/2, and 3. If I go to my calculator and I type in my original, I'm going to see that at negative 1 it shoots straight through. At 1/2 it shoots straight through. And at 3 it shoots straight through. Right? So I know I'm right. Remember, if it bounces, there needs to be a multiplicity 2 there because it's a point of tangency. If it does the curve through it, that's a point of inflection. You're going to have 3 of them there, multiplicity of 3. So you get 3 factors that look exactly the same if that's a point of inflection exists, right? If I had a graph that looked like this, I'm going to have one factor here, so like x plus 4, let's say, and then I'm going to have x minus 4 cubed because I have that point of inflection running through at 4, right? We talked about that. So we solved this one. It would be x equals negative 4 and x equals 4 multiplicity 3. You have to say multiplicity 3 when it's in it. Solve it. Yeah. Yeah. You'd have 1 and 3. Yeah. Okay, but that wasn't actually part of this, so we'll kind of caveat. Okay. Next one. Ooh. So, what's the first one I can use here? X equals what? Pardon? It's the first one, and it's actually the only one, correct? Because the other two are actual decimals. Now, I type that into my calculator. Everyone type that into your calculator quickly. Type it in, 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 type it in. Into your y equals, and press graph. How many x-intercepts do you have? How many times does it cross the x-axis? This one crosses the x-axis 3 times. True statement? 2 of them are decimals. 2 of them are not whole numbers. Do you see they're not crossing through the lines? They're decimals. If they're decimals, you're going to be using quadratic formulas to solve. That's what's going to happen. If they're whole numbers, you'll be able to factor them, correct? Or like when we had a half, that was at 0.5 directly in the middle. That. But if they're a decimal, quadratic formula is going to be used. That's what you solve. So I take my 4, I count down 3, 2, 1, 0. I can rocket count. I use my coefficients. I have x minus 4 as one of my factors. Drop my 2. 4 times 2 is 8. Add it, negative 6. 4 times negative 6 is negative 24. Added is 1. 4 times 1 is 4. Added is 0. And now I get 2x squared minus 6x plus 1. I can't factor it, so I'm going to write it as my degree 2 or quadratic factor. Because there's nothing in the world that multiplies to me 2 and adds to me negative 6. True statement? So if I ask you to factor this instead of solve, box it, move on. It's factored, right? Factored, this is factored. So if I asked you to factor, you'd box it and you'd move on. There's nothing I can do. Okay? What's done worst? Factoring. Because you guys will try and keep going. So you have to stop yourself. That's as good as it gets. If you have to use the quadratic formula, you're done. Because you can't. That won't get you a factor. In order to get more factors, you'd have to be able to factor it. And if you can't factor it, you can't go any further. You're going to have a quadratic factor. You box it, move on. Okay? But this one doesn't say factor. I told you to solve these. Yes? So I would set each of my things equal to 0. I get x, each of my factors. X minus 4 equals 0. X equals 4. Got one answer. Then I go 2x squared minus 6x plus 1 equals 0. What multiplies can be 2 and adds can be negative 6. Nothing. So this is in the format of the quadratic. Look at the very top of your formula sheet. It says, for the form ax squared plus bx plus c equals 0, you can use this every time. If it's in this form, equal to 0, you can use the quadratic formula. Does it not state that up there? Okay? It says, whatever's in front of the x squared is your a. Whatever falls between the x squared and the x, so negative 6, is your b. And whatever falls after the plus sign is your c. Then I use my formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now people will ask me, do I get that formula? Well, I digress. Here is your formula sheet. It looks exactly like this minus this black edge. Pretend that black edge is this kind of gray one. Take it on. This is your formula sheet on your formula, on your diploma. It even is written like this. That's the actual font. You think this is literally copied, pasted, blown up, put on board. Okay? This is your formula sheet. So if people are like, is it on the formula sheet? I'm like, is it on the formula sheet? I literally ask you the same question. And then they'll be like, no. I'm like, then no. Like, is it on the formula sheet? I'm like, is it on the formula sheet? They'll be like, yes. I will say, yes, that is how this goes. Okay? So if you're wondering if it's on the formula sheet, you just look. If it's on your formula sheet, you have it. If it's not on there, you don't, because I have no control. This is what you get. Okay? This is the formula sheet. Right? Okay. So I plug this in to the formula that is on the formula sheet, and I get x equals negative b, so negative a negative 6, which actually becomes plus 6. Plus or minus negative 6. When you substitute in, you're substituting in for only the variable. So I'm going to get negative 6. I put brackets all the way around it. Put the square. Minus 4 times negative 6 times 1 all over 2 times 2. So x equals 6 plus or minus the square root of 36 plus 24, or you can just literally type it all in without the square root sign. Do not type the square root sign in, because you will get a decimal, and I don't know how to keep that as an exact value, and they will always ask for it in exact values. Yes?
Should the a be 2? Not negative 6?
Yeah. True statement. Accurate. Good catch. It would have ruined my whole thing, and then no one would have said it till the end, and then they would have said it, and then I would have to go back. Thank you. I appreciate that. People will save it to the end, but they'll see that it's happening, and then they question themselves, and then at the end they're like, excuse me, and I'm like, I have everything in a box. And I'm like, we're moving on to the next question. Oh, but back like 77 steps ago, I think that was supposed to be a 2. I'm just like, okay. All right. True statement. So if we go 36 minus 8, which is totally different than adding 24. 36 minus 8, we get what? 28. All over 4. Then I go back at circa grade 10 and I say, hey, can I reduce 28? So I write it over here and I say, hey, I think I can. What perfect square can I fit into 28? 4, 9, 36, 16. You know, all of those. It's a 4. So I can break 28 down into 4 times 7. The 4 comes out and it's a 2. So I get 2 root 7. And then I go back and I say, good job, grade 10 math in my head. And I go back and I replace it. I take this square root 28. Toss it off. I take my 2 root 7 and I put it in there. Or unless you're the person who has root 28 as a decimal sitting there and you're like, how do I work that back? You don't. You went too far. So you do not put root and then all the numbers and get a decimal. Yes? You put what's under the root. Yeah?
We get in trouble on like a written response if we didn't show 4 times 7 and just immediately took it out from square root 28 to 2 square root 7.
No. Because that's grade 10 outcome.
Yeah.
You would get in trouble if you don't reduce it. So some people will leave it as root 28.
Yeah.
If you leave it as a root 28, you will lose 0.5. You need to reduce it. Always in the most reduced form. So I come back here and I get 6 plus or minus 2 root 7 over 4. And then I look at the triangle and I say, can I take something out of all 3 of these numbers? Yes. If this wasn't a 2 in front, say it was 6 plus or minus root 7 over 4. Say that didn't exist. Some people want to take it out of the 6 and the 4. You can't. It has to come out of all three or you're not allowed to. Does that make sense? So if there was only a 1 in front of my root 7, I'd be done. Box it, move on. Do not. People will have perfect answers and then they're like, it must be simpler. And then you like cross off more things and then it's like root 7. And I'm like, what the heck? Then I'm like literally like X 3/4 of your work and then I'm like, back here, you were right. Stop the madness. Because like you'll just like, it must be better. And it's like, no. Okay? No. So this one I can take a 2 out, I get a 3. This one I take a 2 out, I get a slanted 1. This one I take a 2 out, I get a 2. And so I get x equals 3 plus or minus root 7 over 2. And then comma 4. Why the heck did I put comma 4? Because it's another answer. Oh, look at that. It doesn't know what to do because I have too many fingers on it. Oh, yeah, there it is. But if it said factor and not solve, this would be gone. I would be like, yeah, woo, woo, yay. Now, are you the person who, when it says factor or solve, box both and say, figure it out, Lepp? No. That means you had no freaking clue, and you're just putting both. It's like putting your B, and like, you know, and you kind of like put a little bubble on the other side of the B and hope that the teacher guesses if it's a D or a B. Like, you know, the false and the true, where you kind of put a little bit of a line, and you hope that the person takes between true and false, that it's false or true, and you hope your teacher just picks, because you don't have a freaking clue, so you put like the 50-50 true false little letters. Remember those? That's the same as boxing both answers. Okay? Bad news bears. We don't do that. It said solve. So and then it's like, yes, this child knows that this is solving. Can I get an amen? And then I'm like, yes, check mark. 3 out of 3. Boom, shakalaka. And then the person after this boxes both, and I'm like, deep breathing. And then it depends on how I feel that day. Like, do I feel like not taking marks off and being like, oh girl, you would have lost 0.5 because you boxed both of these, and then I can write you a paragraph and then keep the mark? Or do I like take the 0.5 off and still give you the paragraph? That's like, box both. You check box both. You know? Yeah. What's this one? X equals 3. You guys are answering so much faster now. I think you just want me to carry on. 4, 3, 2, 1, 0. 1, 6, negative 6, negative 45, negative 54. These are such wonderful numbers. Drop the 1. 3 times 1 is 3. Add it, 9. 3 times 9 is 27. Add it is? I don't know where I was going with this. Okay, 3 times 21 is 63. Add it. 3 times 18 is? We're hoping, because what happens? Yay. This is a 21. So now we have 1x cubed plus 9x squared plus 21x plus 18. What do I get when I do that one? Don't all answer at once. I forgot that. X equals negative 6. Boom, boom. 1, 9, 21, 18. 1 times negative 6 is negative 6. Added is 3. Negative 3 and negative 6 is negative 18. Added is 3. Wow, we're really getting a lot of 3s here. Negative 6, negative 3 is negative 18. And we're happy. Get a 0. Woo! X squared plus 3x minus 3. We can't forget the x plus 6 up here. I really wrote that too far. I'm going to pretend I wrote it here. X minus 3, x plus 6. X squared plus 3x minus 3. And because I'm a borderline genius like you, I would type the equation into my y equals, and I would see a graph that looks like this. Please don't judge me. It looks something like this. Okay? Something relatively similar. So this is 1x intercept. This is 2x intercepts. This is not happening. Right? Watch this. This gets me 1x intercept at 3. This gets me 1x intercept and negative 6. This I know is going to backfire. what do I know? What does it mean by backfire when I put in the quadratic formula? I'm going to get a negative under the square root because it's not going to give me any solutions. True statement. Right? Gets me one, out. So let's prove that I'm right. So we're going to go x equals a, b, c. X equals negative 3 plus or minus 3 squared minus 4 times 1 times negative 3 all over 2 times 1. X equals negative 3 plus or minus. Something is wrong with what I'm doing. I'm going to get a positive.
Is it just positive?
Don't know what you're talking about. 4, 8. Wow. Yeah. There we are. And, going to be blatantly honest, if you can put it into your calculator and reason what it looks like, you'll catch yourself. Because I knew immediately this needs to give me a negative under there. And I knew that what I was doing was going to give me a positive, and it has to be a negative because there are no x-intercepts left to get. Correct? So if you understand what your graph looks like and what your outcome should be because of it, you'll catch errors. Like I went, oop, I'm going to get a positive 21, and that can't be good. I need it to be negative because I can't have any more x-intercepts. I've already got my 2. Right? So now I go 3 minus 12. That is not 3. 9 minus 12, which is negative 3 over 2. And then I'm like, whoa, can't happen. And most people are all disappointed. Stop it, Micah. My goodness. You guys in those windows. I'm going to have to like close all the windows and become vampires. Okay, that might be going excessive. Okay, just closing the windows. We don't need to become vampires. Now, most people will freak out when they see a negative 3, right? Your inner being will freak out. You're like, it doesn't work. Oh my gosh, what do I do? Ah! But your inner being in grade 12 will not freak out because you're geniuses and you've looked at the graph and you're like, x-intercept, not going to work. Got my x-intercept, it didn't work. Boom, boom, boom. I rock. I'm so awesome. I like the negative 3. I needed a negative. Yes. Good. Check mark, and you move on. Instead of the person who calls me over and they're like, it's negative. It doesn't work. I'm like, why did you do that? And I'm like, box it and move on. And you're like, no, it doesn't work. I'm like, box it and move on. And I'm like, you're right. Can you box it and move on? We can discuss this later. And then you don't trust me and you change it. It's aggressively hard, but well, that wasn't nearly as good. So, no solution. That creates no solution because the solutions can't exist, right? So what is my answer? X equals 3, and now my head's kind of burning, and negative 6. I shouldn't have done that.
You shouldn't get a mark this time.
That's true. I had marker on my hand last time. Colin was a trooper, told me. All right, so I'm going to hand out your polynomial handed. Now, just so you know, we have not went over graphs. Tomorrow we go over graphs, correct? That means if they ask you for x-intercepts or y-intercepts or domain or range or the possible number of x-intercepts or the possible number of y-intercepts, you're not going to do those questions, right?
Oh.
I am not giving you homework tonight, so I expect you to work on all the questions that you can do in the handed, okay? Your handed is going to be due next week. We are moving on to trigonometry Monday already, so that's fun.